Hello everybody, my name is Mike Paltosh and I wanted to show some friends, family, and coworkers who have been asking what it's like to work on a video game. To that end, I'm going to create a character and go through the different steps, including sculpting it, texturing it, boning it, animating it, giving it some AI, not very much, and making it run around in my upcoming video game, which is called BlastMorph. I've been working on it for a year and hope to have it done by the end of this year. This is not really a tech tutorial, as I won't be getting into very much depth on the material. It's more just showing what it's like to go through the workflow for people who might not really know the first thing about what is involved in this process. So let's start by sculpting our character. So here I'm in Maya, which I've been using since I was taught an early version in college. Blender is a free version. 3D Studio Max is another, and when I say version, another modeling program where you model 3D objects, characters, even movies use these programs. So this is the one I'm most familiar with. So this is where I'm going to create this character. So the first thing I'm going to do is create a cube. And this is what my character is going to be sculpted out of, believe it or not. And sculpting is, it's very much like, clay sculpture, wood sculpture, stuff like that. We're just going to change, a lot of these control vertices, these little points, to turn this collection of polygons into a character. That's basically the underlying process. So the first thing I'm going to do, because my character is going to be symmetrical, I'm going to cut off half of the object here, and instead of sculpting the left side and then the right side, I'm going to sculpt one side and then just duplicate it to the other side, so it has perfect symmetry and cuts the work in half. So the other thing I do when sculpting something is have a template. And so I actually created some templates using some selfies, I guess. So I just created this, me in a T pose, what they call this, and this is kind of common. You want to create a character with as few bent joints as possible. So this is kind of the standard pose that you create. There's plenty of reasons why we don't use bent poses when we create the base default form. One thing is if we had a bunch of bent joints and then try to deform it later to create animations, it's hard to get, if you start off with bent joints, hard to make the joints look straight, bend into joints, as opposed to if you start off with straight joints, when the joints bend, they deform better. It's also easier to skin, but I'll get into that later. So anyway, how do we turn this cube into something representing a person? Well, basically, we've got these three different views, and we'll line these things up and start. Let me make this a bit transparent. And we'll start just kind of mirroring the shape. As you can see, just try to align these to the character. That includes things like creating new lines, new control vertices where you need them, and moving them appropriately to better mimic the character. Also includes extruding, new limbs, and really this is most of the sculpting. And it's actually kind of meditating in many ways, relaxing. One thing, later we're going to make this character bendable, basically, you know, so he can move, rotate legs, rotate arms, and that means we want to have more of these control vertices and lines near joints so they deform properly. A lot better. The more subdivisions you have near joints, the better it's going to deform. Same with things like elbows, necks, stuff like that, wrists. Now the other thing is you don't want to have too many of these vertices, especially when they're not needed, because the more vertices, the more polygons, and the more performance it takes to actually render this guy. So you get into a trade-off. The more you have, the better it looks, if you do it right. But also, the more expensive this model is, and if you have 100 running around on the screen at a time, even with the most powerful machines today, you can still bring them to their knees. So yeah. And there's a lot of different techniques that can be used, including switching between models with fewer polygons when they're far away, and using models with more polygons when they're up close to the camera, stuff like that. We're just going to focus on a single model for the purposes of this. But yeah, so this is the very beginning of our model. And I mentioned that we're going to duplicate it, and that's kind of what this is. Now obviously, it's neat around the corners and stuff, but this is the very beginning, and I'm going to fast forward through pretty much the rest of the sculpting because it is going to take a while. But yeah, this is basically the start. This is step one, sculpting the character. Okay, let's try fast forwarding this. And so, after moving a lot of lines and vertices around, we've got, fairly medium resolution character sculpted. Just under 1,000 faces. I've got a left and a right half. And yeah, so that's basically the sculpting portion. Now, obviously we don't want a gray character running around the video game. We don't want it to just look like a player in shape, but actually a person in color also. So that's where texturing comes from, which is the next step. Basically that takes an image and maps it onto all these polygons. Instead of modifying these vertices in 3D space, we modify different vertices in 2D space to map textures onto here. So for example, the texture we'll be using, I basically took the same pictures of me and just put them together in a single image. Some have higher resolution, like around the face. This isn't a very optimized image because they'd be better packed in regular video games. There's a lot of dead space that we won't be using here. But again, this is just kind of an example. It's also not very high resolution, as you can see, for the most part, but that's fine for now. Also, you'll see that I kind of disfigured my head, took a front visual and put it on a side. This is so it's easier to map. You can kind of wrap the model around the entire texture here. So anyway, let's see how this works. So I'm going to take this and apply the texture onto it. Now obviously this doesn't look good. That's because we need to modify the location of all these vertices in this 2D file. So let's see here. So as you can see here, these vertices map to these vertices here. And again, because I created this from a cube, it's still got a lot of the basic cube texture mapping, which obviously isn't working. So for example, let's start a very simple remapping. We are going to create one mapping for on the z-axis, and you can see that it's basically remapped all these vertices to this texture here. So if we display the image, we want to line up a lot of these with mapping, and you can already see what's going on. The shirt and the pants are already starting to line up. The face, but we're going to remap the face and set it onto this low resolution one. We're going to use a higher resolution one. Same with the arms. And yeah, so this starts turning into something very similar to what we did with the 3D sculpting. I'm basically going to go through and modify these 2D CVs, like for example on the belt here, to map better with the texture. So as I move these, the texture moves. Again, the 3D location of these no longer move because I'm modifying a different mapping, but instead the texture moves. And so I'm going to go ahead and do another fast forward. Well, actually, yeah, we can do a few more things before I go into fast mode. So for example, the head here, we want to map that a little bit better. So we're going to select those. We're going to do this at an angle. As you can see, I took my face image at an angle. You don't want to do it straight on because then you only can kind of map it to the front. You do it at an angle, add some side, and you can improve what you are, all the different angles. So let's see, maybe that. We'll take a camera-based mapping and create this at an angle. Okay. Flip it, and let's see the very first. Yeah, kind of creepy. And honestly, this will probably be creepy when it's done anyway, but we can improve it a little bit. So yeah, you can kind of see how things are starting. We want to match hairlines up. We want to get the eyes in the little inset area there. We want the mouth to focus on the lip area. We want the nose to kind of go down the center. So we're just gonna keep modifying these. Try to minimize the distortion that shows up on the model. Without trying to make it look too weird, but again, it'll probably be kind of creepy when we're done. But the thing to remember is in the video game, it's probably going to be viewed about this distance for the most part. So we don't need everything to be perfect. So yeah. And then the same thing with the arms here. I'm not going to use the current mapping. I'm going to use a separate mapping. So I'm going to take the arms here, rotate them, and start, yeah, making them work with the slightly higher resolution image I created here. And so yeah, so I'm just going to go through and again fine tune this mapping so things line up, you know, closer. Really, it's just kind of going through and tweaking it little by little till you get to a point you're happy with. Okay, here we go. Okay, so I think we've gotten our model textured pretty well. Guess that's a relative term. I mean, it still looks, you know, in many ways unrealistic and kind of creepy. I'm sure you've heard of the uncanny valley that happens when you try to make a model too realistic. And, you know, that's with professionals coding. I have more of a uncanny crater with my models, but that's fine. Again, we'll probably be seeing him from about this distance. So, you know, that's fine. We'll see how the reviews go, but yeah. So yeah, got the texturing done. Now you can, where's that? The more I look at, you know, the more I find more places I can be fixed up and improved. So yeah, so let's focus on moving on. So yeah, we got sculpting done, we got texturing done. Next up is, it looks like we want it. Now we need to make it act like we want it to. How do we give this a walking animation, or even, get him to put his arms down? For that, we're going to use a skeletal system. And unlike a skeletal system in us, which holds us up and gives us some rigidity, the skeletal system for 3D models basically help dictate how they move. So I'll show you one. I'm not going to go into creating the skeletal system. I'm going to reuse one that I've been using a lot that I created for a bipedal model. And as you can see, the skeleton has a whole bunch of different, bones. And basically how this works is the vertices in the skin here, in the model skin, will associate themselves with one or more of these bones. And as these bones move, the skin, the associated vertices will move based on the bone. So they kind of give you a realistic looking movement set. If your bones are correct and your model has properly placed and skinned vertices. Let's kind of show you what I mean. So first of all, we're going to attach the skin to this model. This is basically going to do a simple pass and just associate each vertex with the closest two bones in this case. So we do that. Let's see how this behaves. In fact, I'm going to give it an animation so I can go back and forth. Okay, so as you can see, it's kind of doing some good stuff, but not completely. For a good example, let's check this out. So what's happening here? So some of the chest vertices have associated themselves with the upper arm bone, which isn't right. The upper arm bone shouldn't have any influence on the chest, really, or at least not this much. So we're going to have to remove the upper arm bone influence on the chest here. Let's check out the legs. So you can see he kind of gets sucked in. Again, the upper body, or the stomach area is being influenced by the upper leg, and the knee kind of gets small because the lower leg is influencing the upper leg. This is always a good freaky one, the head. So yeah, obviously deformed. Again, the chest, it's got some chest influence on the chin because it was close enough, and that's not what we want. So what we do here is change the weight of the vertices and how they map to bones. Many ways to do this. The way I like doing it for the most cases is actually use this tool where you can actually see the influence of each bone. So right now the pelvis bone is showing the influences. So black means it's got no influences. Colors, blue is a little influence. Let's see here. All the way up to red to white is a full influence. So you can see, the pelvis is influencing things that probably really shouldn't be influencing. So for example, let's remove influence of the pelvis on these legs here. Yeah, actually no, not that much. down here. Okay. So what would help the visualization is, yeah, okay, so we don't want the leg to influence the upper body. So if I remove it, the upper body goes back to a proper looking view. And then pelvis, let's remove some of the influence on this leg here. Let's just do that and see how that works. There. That's a bit too much. Let's smooth it out. Give it back some influence here. Yeah, you can kind of see what's going on. But yeah, again, this is just kind of a process of going through and massaging a lot of the vertices once again. This time to make things move properly. Actually, also another thing you'll see is left leg influence on the right leg, which we don't want. So we can remove that. There we go. Hip. It's a little better. Let's add some more influence back. And that should work for there. However, we don't want the right hip to extend all the way down here. Otherwise, it'll mess up the bottom of the leg. There we go. And likewise, we don't want the right hip to exert its influence up here. Otherwise, it's going to deform the top of the hip. So now we're kind of getting a better, the bone, the areas around the bone are kind of keeping their shape properly. Let's see what the foot looks like. This might more or less be okay, but let's work on that. We don't want the, oops, I want to remove influence, not add it. The knee should really not do much with the foot movement. Go. Okay, so I'm working on one side, and again, there's a shortcut to flip this over to the other side because, you know, the other side has nothing done to it. And instead of going through and completely doing the exact same changes, I can just mirror the weights from the right side to the left side, and now the left side should behave the same. And yeah, so yeah, again, this is just more going through. Let's fix the head real quick. So we got the neck here, and really I want the neck joint to just control the entire head. I want to consider the head just a complete rigid body for the most part. So yeah, white means 100% of the influence of the neck in this case will be used on these vertices, and we will flood that. Okay, but now you'll notice that the head still kind of deforms, well, quite a bit. So even though it's got 100% of the neck influence, it's still got influence from other areas. Let's see what other areas. Chest, no. Collar, you're right. Okay, so the collar is, yeah, giving influence. We don't want that to be the case, so let's remove it. And as we remove it, you can see that the head stops deforming. Over. Now the head will stay pretty rigid. We still want some influence on the neck. So the neck actually bends. Let's lower the influence so it bends a little bit better. There we go. Let's check shoulder blades. Shoulder blades are in check. And while we're here, so shoulder blades, yeah, we do not want the shoulder blade to really do much on the arm. Let's get rid of that. See how that works. The big issue that we want, though, is to get rid of the shoulder, which is what I call the upper arm here. So we don't want our chest to move that much. Yeah, even that. Yeah, that's not too bad. At least it doesn't cave in the chest now. Similarly, we don't want this upper influence, upper bone influencing anything on the lower arm. And then likewise, next joint, which is the elbow, should only influence elbow stuff, not even the hand, I would argue. So as we bend, yeah, we could, yeah, improve the flexing there. And this is why it's important to have more control vertices and lines near the joints. The more you have, the more you can tweak the influence. You know, make the ones closer have more influence and the ones farther out. But yeah, for now, this is pretty good. Things are deforming fairly well. The neck, I think, yeah, let's smooth it out here. Let's also see how his chest is deforming. Usually what can happen, well, that's not too bad actually. That's a bit rigid. So let's check that out. Color. So yeah, it's quick drop off there, and the quicker the drop off, the more blocky the animation's gonna look. So if we smooth this out, well, let's do it manually. If we flood, we're gonna kind of botch up the neck again. So kind of improve the drop off rate. I think also I'm seeing, yeah, probably lessen this. Yeah, for the range that we'll be doing that should be good. And of course, let's apply everything to the other side. So yeah, so this will help us move the model in the game. We'll basically just be modifying the rotation of these joints to make them do walk animations, throw animations, whatever we want to do. You know, I could also go down to the hands, but I think, you know, for this point, we're good with this state. So yeah. Yeah, so next up, we will be exporting this model, because I think we've done everything we can do in Maya here in the 3D modeling window. And we're going to import it into Unity, which is the application that I use to build the game engine. And in there, we will create some animations for this character and give him some logic, and finally see him just walking around in the game. Alrighty, so we've gone through the sculpting process, created a model, and textured it, and then boned it, which is the process of attaching a skeleton to the model itself. Next up, we are going to say goodbye to Maya and export it into the world of Unity. So we're going to export it as an FBX file. And all the red and the warning and errors are just Maya telling me how much it likes the model. We're not going to worry about that. And we can see that it's showing up. And we can drag and drop it and put it in our video game world. Now, since I'm not doing Godzilla, I should probably scale it down. To something like that. We don't need animations. We're going to animate it in Unity here directly. Okay, got this here, and yeah, let's rename it. And if we even start playing our game, you can see that he shows up with the user there. Now, unfortunately, he's not doing anything. I can run right through him. shoot them, anything like that. No, that's fine. All it is right now is a model, which is just a collection of polygons with their textures. We need to, actually it won't even fall if we raise it up. That's because it has no idea of gravity and no collision detection. Video games try to mimic the real world, but you know, it doesn't automatically know what should come into collision with what. We need colliders for that. It does automatically know what to apply gravity to, so we have to, you know, let the system know what gravity it should be using, if any. Okay, so I'm just gonna do a few setup things. This is gonna be put on a specific layer where it knows it can come into contact with the user. Let's do a few things there. Add component. I want to add a rigid body. This is how it knows to apply gravity to the object. And I just want to freeze some positions, or rotations actually, so it doesn't spin him around. So right now, okay, so we've added gravity. I'm gonna move this down here because the important thing is going to be shown here. He's got gravity, but if I start running the game, he's just going to drop through the world because, again, he's got no collision detection. Yeah, let's put that there. Okay. So let's give him something that he can collide with. So we're going to give him a capsule collider. There's a bunch of different types of colliders that can be used. In this case, we're going to use a capsule collider because it kind of mimics the shape. There you go. Okay. So yeah. So now the system can test to see if this capsule is colliding with any other objects. And for example, like this ground has a box collider, which is why the player doesn't fall through the world. And now, if we start playing, you'll see he'll actually land and not fall through the world. Now if I have the player come in here, I can even kind of knock him around a bit. But he doesn't respond to bullets or anything like that. That's fine. Next up, we're going to give it some logic. So let's start adding some logic that allows this character to interact with the main player, among other things. Also include interact with bullets, so it will flash when it gets hit. Again, like the bone structure in Maya, I'm not going to go too deep into the logic. I'm just going to reuse stuff I've created. So I've got a component here. That basically allows me to drop in reusable behaviors for this enemy and visual handlers. The reason we need different visual handlers is because not all the characters in this game are polygon based. Some are sprite based, like think of old Mario side scrollers. Actually kind of like these things here. They're just flat single images. And when something like that gets hit, you don't change it, the coloring of multi-polygons, you just change one texture. So to be as flexible as possible, I am adding the ability to choose which type of render to use. In this case, it's a skin mesh. And then behavior, for now, let's just do a simple no-op behavior and see how this works. Okay. Okay, still not falling through the floor, that's good. The guy comes in here, if I touch him, the character gets hurt, which you kind of expect. And if I shoot him, he actually reacts. He actually reacts a bit too well. Let's give him a little bit more health, which is also something that you can quickly change with this logic. If I shoot him, he'll actually flash. And then eventually just die. Okay, that's great. But let's give him some better behavior. Make him move around a bit more. First thing I want to do is actually adjust this. I want to encapsulate the visual stuff inside of another model. Layer. Okay, now instead of this no-op stuff, I want to create let me look here. I want to make him walk back and forth. When he gets to a wall, I want him to turn around or start moving the other direction. When he gets to a cliff, I want him to not fall off, but again, turn around the other direction, kind of like a Goomba would in the old Super Mario Brothers. So for that, I've got this enemy bounce logic. And what that does is make the player move back and forth, and when it runs into the wall or a cliff, it will start moving the other direction. But again, some things you don't think about in video games is how does the character know that they're at a cliff? You know, we would just look down and see, oh, there's a cliff there, turn around. Or how does it know it hits the wall? It's not that simple in the video game world. So what I've done is create what you do is basically test. Every frame you test to see if the player's at a wall or at a cliff. And you test with, in this case, plenty of ways to do it. I'm just doing a simple way, just creating a point here. So this point, let's see, let me put that on the model. This will be right in front of the player. And the player will use this to see if it's at a cliff. So as long as this point is inside the collision detect, you know, the collision, the collider for ground, it knows the player can keep walking. As soon as it emerges from something, it knows that it's at the cliff and the player should start moving in the other direction. We can use something similar for detecting if the player's at a wall, but I'm using actually a much simpler mechanism in this one. I'm just going to detect if the player actually runs into another collider. If so, turn around. So let me just see that there, and let's see if he manages to bounce back properly. Okay, well, he's moving. That's good. Let's start him there. All right, there we go. Now he's going to bounce back and forth, but he's not rotating, which, besides looking weird, ignoring the fact he's got no animation, is also not going to help because this needs to stay in front of his movement. So that's fine. I mentioned these components, these plug-in components I have that I use to give the player enemy. Well, I've created many types of them, and sometimes I want to use more than one at once. So I created this aggregate behavior, which lets me take multiple behaviors and run them all at once. So I'm going to have him do the behavior where he moves back and forth, turns around at obstacles, and then there's another behavior. Just going to copy it off my cheat sheet here. Which has the enemy always look in the direction that he's moving. There we go. So when the movement reverses, the player should turn around and face the other direction, which will look a little bit better and also keep the cliff detection in front of him, so it actually works. Okay, let's add the look at logic to the list of behaviors we're going to be running and see if this works. All right, we have our model bouncing back and forth between both walls and cliffs, and it's also being hit with the user interacting, hurting the user. Let's actually show the game. It's a user. You can even see in the top right hand corner here, I've got name and a health bar. And I can even get a power up when I kill him. So we've got all the logic and stuff like that going. Last thing, let's add some animation to the character. After that, we'll have a full enemy and we'll be done end to end with this. Okay, so what we got left? We have animation. He's doing everything right except looking like he's actually walking. So how does this work? This is where the bones and the skinning comes into play. So first off, we're going to create an idle animation. This will be good excuse to just show how the simple animations work. So for example, he's had his arms up the whole time. I'm sure they're tired. Let's finally put his arms down. So we want to grab the bones here and just have him put his arms down. And to make him a bit more realistic, just move his elbows up a little bit. There. Now when he's not moving, we'll just have a standard pose, and that he still looks a little bit stiff. You know, we can make him hunch over a little, relax his neck. But to be honest, this character is not going to really spend any time standing still, so I don't really care what he looks like when he's idle. But it does show that, you know, when this animation is running, he'll go to the relaxed pose, otherwise he'll go back to his T pose. The animation that he will be doing pretty much his entire life will be walking. So let's create this. Again, we'll have the arms relaxed a bit. But we also want a walking animation. So what I'm going to do is move his legs appropriately. And let's see, I'm going to start off moving his right leg, making his right leg be on the forward animation, meaning that his left leg will be supporting him. The next step will be his right leg all the way forward, right before he puts his foot on the ground, and likewise his left hip will be all the way back. You can already see, and then the animation will basically interpolate, so I don't have to put every single frame. I've just got 2 frames, and it will move the bones in between those frames, and those bones will move the vertices of the model. So yeah, it's basically a whole bunch of different abstractions on top of each other. And then also we want him on the ground, so we're going to have some pelvis movement. There we go. Next frame will be just like the first, except he'll be supporting his weight on his right foot. So actually, let's take this frame, put that there. And, you know, again, this is just a real poor indie developer working on this. You know, the big studios, well, the medium-sized studios or whatever, will often animate these characters back in Maya and export them. They'll use inverse kinematics, which is a bit complicated, but it's basically, instead of moving from your, you know, the pelvis down, you'll just move your foot and the leg will move appropriately. I am just doing a very simple way of just animation, you know, no motion capture or anything like that, just kind of doing bare minimum. There we go. And okay, let's see how this works. And we are missing the final loop. I should also be paying attention to how fast the feet move compared to how fast he'll be moving, but I'm not too worried about it. Unless you're way off, it's actually surprising how it doesn't really matter too much. Let's see, just want to look at some. Yeah, okay. Cool. Okay, so we got the legs moving here. Let's just finish him off by making his arms sway a little bit better. Okay, so we're starting here. Let's start with that forward back. Likewise, his right shoulder. There we go. Very simple. Let's see. And yeah, probably also have rotate the hips a little bit. Maybe even make the head move, but this is a very simple example, but should get the point across. So, okay, so the other thing is, this is a very simple character. He'll only be walking, but most of the time you want characters to be able to move in and out of these different animations. You know, when they're stopped, you don't want them to you do not want them to be walking in the walking animation. You want them to be in the idle, and how you would do that is kind of create some logic here where the code would output the speed of the character, and the animation state machine would check that and, you know, swap over the to the appropriate animations. So yeah, in this case, we're just going to always do walk. So I am just going to set that as the default layer. And with that, we should be ready to see our player in action. And well, here goes nothing. Yeah, pretty stiff, but it's our character. He's got some logic. He's got some animation, albeit a bit stiff. Let's see how he behaves. Yeah, and I can add other logic that makes him, you know, when you finally hit him, he could start rushing you, or maybe shoot his own projectiles at you. But yeah, this is basically an end-to-end scenario of creating a player all the way from a single cube to getting him texture, getting him animations, getting him boned, and getting him walking around the game. So yeah, okay, well that's basically it, and say goodbye. Thanks for watching.